Hello, this is Ed Hickey, product engineer for the Allegro PCB editor. In this video, we'll take a look at embedded component design, the basic steps of setup and placement, along with new features in 16.6. We'll be looking to embed both actives and passives over on the left side of this rigid flex design. But first, let me launch the embedded layer setup form, where I will allocate certain layers to be embedded. We're going to embed layer 2 as body down, layer 7 as body up, layer 5 is already embedded as body up, and the attachment method will be indirect, that being the pins are now connected by way of single layer micro vias. The parameters related to embedded components are down in the lower section. The one that I'm editing now is for min cavity gap. I'll begin by placing the first of the two arrays using the right mouse button place on layer command, where you see the list of legal embedded layers. This component's placed on layer 7. The cavity appears in black. The cavity is proportional to the place-bound shape. Next we place the next array on layer 2. Try to place them coincident. Over on the left, I'll window around the group of 10 capacitors, hover over any one of them, followed by right mouse button place on layer 5. With the caps still highlighted, I will now move them as a group using, again, the context sensitive menu. The next step, I'll have to turn off the green layer, which is the cavity layer associated with layer 7. I'll go to the color dialog and make the appropriate adjustments there. You see a merger first of the two cavity layers, and now we'll eliminate the green layer. Moving components to the left to illustrate the dynamic merging of cavities when these components are below 20 mils. With that setting that we said earlier, the cavities will dynamically merge. Some fabricators like the concept of a super cavity. We can certainly do that in Allegro by selecting the cavity shape and use any of the rectangle or polygon commands to create it. Okay, over on the right, you see DRCs that are related to max count and max area violations. In this next segment, we'll take a look at what we call dual contact components. These are components that have contacts on each side. We simply enable a property we apply at the symbol definition level. Let's take a look in 3D to get a better understanding of what I mean by that. You see basically pin contacts on each side of that component. I'm going to now move one of these components and drop it on internal layer 5. I'll use the routing tools now to show we can route from either side of that dual side contact component. I'll begin on layer 5, the base of the component, and use the working layer model to add a series of micro vias that get me to the bottom layer. The right side of that component has been routed off of the top layers. Next, I'll highlight the circuit and go into a 3D mode and spin the graphics a bit to see the view of the dual-sided contact and its routes. Let's end the video by taking a look at another 16.6 feature, two-layer support. For that type of requirement, first you would need to go into the cross-section editor and make one adjustment, that being name the dielectric layer. In this case, I've named it DK_EMB. With that done, I can next go into the embedded layer setup form and now apply embedded type to that dielectric layer. In this case, I have selected body up. Once that is done, we can now go into the editor and drop components directly to that dielectric layer. This concludes the video on embedded component design.